We've yet again come back to HHC to talk a little bit about, well, cellular devices, GSM networks, etc. Some fun that you can have, some things that you can break, and, well, some of the research that we're currently working on. So what are we going to do today? So we're going to have a small insight into, the basic setup of your own custom cellular network, whatever you need for doing practical penetration testing or having a little bit of fun. For that, we do have our own GSM network with us. That's the silver box that we've got lying here on the ground. We'll have a little insight into how the network works. And afterwards, we'll have a look at, well, a few devices that we simply tested in our lab and, well, the findings that we had. So the services that we're going to look at or talk about today are just the same as in a normal cellular network. So we have typical voice connections like a simple phone call. We have text messages. In theory, we would also have something like MMS messages because they are eventually based on text messages with a little bit of data connection. Then, of course, we have the basic text messages running as is. The data, so normal IP connectivity. And we'll also have a few thoughts on OTA updates, meaning update mechanisms that don't run via IP, but actually run via the cellular infrastructure itself and the things that you can do with that. And with that, I'm going to hand over to Henrik for the introduction.
Okay, so let's start with some basics to understand what we want to do or what the kind of setup we need for our experiment. So every telecommunication network, every cellular network, you need, of course, some mobile station, so that the device you want to attack, and you need a base station. Base station can be a small device like this one. This is more or less enough for this room. But also that big devices staying on the roof, so that really big antennas, for example. But the technology behind is more or less the same. It's just, the size. And then we need a core network. The core network at least must have some management identities and a database. The database is storing the authentication information, which you also have if you're buying a SIM card, for example. So on the SIM card, there will be some authentication information, and the provider needs quite the same in his backend. So taking a look to typical networks, we just need that, and then, of course, we need some interconnections to the normal telephony network, to the internet, whatever we would like to have for services. In GSM, it's looking like that. Again, it's looking a bit complicated, but it's quite easy. Again, we have a phone, we have the SIM with the authentication data, we have the so-called BTS, which is just the antenna. We have some controlling units, some control servers for the base stations, like deploying configuration and so on. And then we have up here, some gateways and that management servers. One part usually is for packet data, so internet data via phone. This is usually completely separated from the voice data because it just came later, so in a later development of the standards. And we have here the MSC servers. The MSC server, that's that management entity. So the management server, which is looking up all your calls and which is responsible for the routing of calls and messages. And again, in the back end, we have the HLR, home location register. This is the database. Sometimes it's split up to AUC, which is the authentication center. That is that part of the database which is really storing the encryption and authentication material. In practice, there will be much more behind, so every big provider needs some billing and so on, of course. So all that can be in that database, for example. Then, if you want to go with UMTS, it's a quite similar setup, but it's some newer components are needed there. Because the modulation of the air interface is completely different, we need a new base station. So that is where we have to go here. If we have a new base station, we also need some updates or some enhancements of the management servers. That is that device here on the left. But the core stays the same. So there is no difference in the core between GSM and UMTS. If you now want to go with LTE networks, it's very different. So it's a completely new development. That is why it's very hard to get LTE stuff, than GSM stuff. First, LTE stuff is much more expensive. It's just new. You won't find it on eBay or whatever. And there are new standards. The good one is LTE is completely based on IP networks. So the whole architecture is a bit broken down. We have a new antenna. We have one big management server, one database, and just a normal gateway. That are the components here on the left. Okay, jumping back to our experiment to play around with cellular stuff. What do we want to go? More or less, we need to simulate somehow a real-world environment. So nobody or the device should not see that it's not connected to the real network. So it should come to our network and everybody should think, oh, I am in my normal home network, for example. Otherwise, there could be some countermeasures maybe of the device, or I don't want to connect to that network or whatever. Then we want to intercept mobile data first. That's important. If we think about some telematic modules in cars or in some small IoT devices, they will mainly use mobile data. So that's where we want to go. But also maybe it's doing some calls, it's using SMS, whatever. So there will be a lot of services. If possible, because we want to do some security evaluations, we need a kind of raw data access. So we need all layers to be accessed by us. We want to send as much raw data as possible to do implementation fuzzing, to take a look to the stack, how is it working. So probably I would prefer open source variants to be used, because there we can manipulate the code and have a deep dig into the implementation there. Maybe, if possible, I like to use a portable setup, like that small device here, because sometimes it's not that easy to bring all the stuff to me. Like if cars nowadays have, for example, GSM or LTE uplinks, I don't want to bring the car into my lab, so I want to bring the lab to my car. And of course, then we want to observe somehow what's happening. So we need monitoring capabilities. I'm coming from the IP world, so if possible, I want to use Wireshark to take a look to the traffic. So what's going on there? Yeah, so at the end, that are our requirements. And more or less, we are building a Stingray, an IMSI catcher with it. So that device is also the surveillance agencies are using. Think about it. Which tools are there? What can we use? So we took a look to the market. That is all the open source market only now. So most of them are open source. There will be some more software available, but you really have to pay a lot of money. So all the big vendors like Nokia, Huawei, Ericsson, whatever, they want a lot of money for the network, of course. And here that are open source projects, so you don't have to pay anything for that. So maybe for the hardware like the antenna, you have to pay something, but for the rest, usually it's open source. For GSM, I split up this listing to phone and network stacks, so it depends on which direction we want to test. There exist also some projects for the phone itself, but now we need the network. The network, there exists a project called OpenBC or Osmo BTS, Osmo BC. It's the so-called Osmo community. They implemented a lot of stuff in the GSM area in open source. And this one is quite, working quite well. So we are also using that here. Then there are some other projects for UMTS. That is an enhancement, got published beginning of this year. So with that one, you can also use UMTS networks. You just need a different antenna. But in that core network, in the implementation, they are supporting GSM and UMTS. For LTE, it's looking quite different. There are some implementations where you can play around with phones, so just to do sniffing, for example, and some implementations for the network, so for the base stations here as well. For example, OpenLTE, SIS-LTE, or OpenAI interface, that are the open source software which is currently existing. There are some few more, but the problem behind is none of them is really stable. So for our setup, we can't use LTE. Only GSM and UMTS we can use for our testing purposes at the moment. There is some stack which is quite good, and this is more or less stable. It's called Amarisoft, but this is not open source. So you have to pay money for that. Good. So we decided to go with OpenBSC and Osmo BTS. And that is how our network is looking like. OpenBTS is the antenna. It's also an open source stack for the base station, for the antennas. We are not using that here. We are using a small base station we got from eBay, about $100 to $200. This is this one. This is a closed stack for the cellular, but we can use it very good with the open source core. So we just don't have the Osmo BTS, but we have the OpenBSC. For the Osmo BTS, you also need an USRP, so it will work, but it's not that stable, so that is why we are using that here. We are using OpenBSC as core system. That is that big management server. It comes with an SQL database, which is emulating an HLR, so that database where the authentication information is stored as. And as a front end for that, I'm using so-called simple HLR. I will show later what that is. It's just to somehow manage the data which is in the SQL database. It's better than always execute queries on my own. For the data part, so for the routing of the mobile data, there is also an enhancement of the OpenBSC project called OpenSGSN and OpenGGSN. It also comes with that software stack. So they are delivering us everything we need. Then, of course, we need an internet uplink and maybe some additional interfaces like an SMPP interface for getting and sending SMS. That also comes with OpenBSC. Then if we want to modify that a bit more, for voice connections, for example, usually the voice is just staying inside of my cell having that setup. But OpenBSC has the possibility to use voice over IP. So we connected OpenBSC to an asterisk server, and with the asterisk server we can just route all the calls in our network to some SIP gateway we can find in the internet. So now we are also able with our setup to make phone calls from the mobile to somewhere else in the world. We just have to convert all the data to voice over IP. Then for packet spoofing or to inject packet, whatever testing, we have a framework called Dizzy that we connected to the OpenBTS or the OpenBSC, and then we can also play around with the packets. Good. So far about the setup. But why is that working actually? So this base station is just sending some broadcasts about a cell. The broadcasts include so-called mobile country codes and mobile network codes, standing here MCC and MNC. That way, a cell is identifying itself. So is it a Brazilian cell, if it's a German cell, a US cell, that is standing in that broadcast. Furthermore, the MNC is also identifying the network. Network means Vivo, Claro, TIM, whatever, T-Mobile. This is just a number which is assigned here, and the phone is looking up in a list. It has from some updates or stored in the firmware which provider that is. It's also on the SIM, so the SIM card is also defining what is my home network, so to which provider I'm belonging to. Then, if a device connects to our network, we need some kind of authentication. So on the SIM card, every phone which wants to connect to a cell, or every device which wants to connect to a cell, wants to authenticate against the network. Also, there will be some encryption behind. Fortunately, there are multiple standards how to do that, and there is one algorithm called A50. A50 means there is no authentication and there is no encryption. So it's just ignoring all the keys. That's something we also can give to our cell, so we can say we let every cell in. Of course, so in a normal setup or in our setup, we don't have the keys. We are not the provider, so we haven't sold the SIM cards to the people. Maybe we can buy our own ones and exchange the SIM cards, but sometimes it's not possible, especially on having embedded SIMs. Think about that. But that way we can just disable everything, so we don't care about authentication and encryption. What else do we have? Phones are configured with an APN, an access point name. That's the gateway which is used for mobile data. So every provider has some gateways. Internet, for example, is one common one. Also here in our setup, we can just define, we are accepting every gateway, that's fine. It's in our hand, so we can configure what we want. For SMS, there is also one configuration on SIM card or phone. It's called the SMSC number, so the SMS center number. Also there, same way, we can configure what we want in our setup. Some limitations we have, yes. With that setup, we only can do GPRS, Edge, and UMTS for mobile data. For LTE, that stack is currently not supporting that. Sometimes that we also have seen, especially for some IoT devices, they always have to use a special APN, so a special gateway, and that is only accessible via that SIM card. So it's doing an authentication against that somehow. There we also must trick around, or for example, we have to remove the SIM, pack into our phone with that OpenStack, and route everything over that phone if we want to access some devices here. Okay, let me just show.
So basically what Henrik is doing now, he's switching over to exactly the setup that we've got running, and we'll just give you a quick walkthrough through the configuration files and the setup.
Yeah, so this is the configuration file of our core system and of our antenna, more or less. Here we have, of course, a password internally used. We have some log information. We can note down here, so just for debugging. We can't see the left side, right? So maybe that's much better. And here we now have the configuration of our cell network. You see, it's just a number, the mobile network, the mobile country code here, and the mobile network code. We can change it to whatever we want. And then that broadcast is changing, and the devices think we are in their home cell. At the moment, I think it's Vivo. Brazil, the number is 724, and 01 is Vivo. As short name, that's just a name which is showed on the top of your phone, like you're connected to that provider. At the moment, we have HUHC here. But I also can change to Vivo, so nobody will ever notice that it is connected to our network, for example, because the name is not changing. The phone is not showing you more. It's only showing that name I'm typing in here. For our test, I'm using auth policy closed. That is defining who is allowed to connect to our network. I'm just saying I just let in SIM cards I know. So stay tuned. You are not in my cell. And here is the configuration A50. So I don't care about encryption and authentication. Good. Back to the slides. Now, we have some device, like you have a lot of phones here in the room. I have a phone there. Maybe some IT devices are also here. We tested it with some. Brian will show later. But how to get them into our cell? That's now the big question, because we want to do some assessment with it. So we want to take a look to it. We want to hack it. Usually, if a device wants to connect to a network, it is building a so-called cell selection table. The cell selection table is based on multiple factors. First factor is, I'm taking a look to my SIM card. Is there a network stored on it? Like, I have been connected to that cell, I want to stay in that cell. So if I have been in a cell or I'm currently in a cell, I will stay in that cell. So it's not switching from cell to cell all the time. Then, if there is nothing on a SIM card or I can't find that cell, the device is trying to connect to the home network. Home network means the network where I bought the SIM card. Preferably, it's always the best and the loudest cell, so the one with the best coverage. If the home network is not available, I will go to a roaming network, so to a roaming partner maybe. That can also be on the SIM card. If not, it's just connecting to any cell. So any cell which is letting me in. Some providers are not letting in your SIM cards. So they are testing if you are from a specific range or from a specific provider, and then if they have a roaming agreement, for example, you can also connect to them. If there are multiple cells available, again, the device will connect to the loudest cell available. If we want to force some devices into our network, there are some challenges. Because, I mean, if I have a phone and I'm staying in a cell, it will stay there. So I have to force sometimes to my phone or my device to connect, to change the cell. What can we do there? We can, for example, just do jamming. And we just jam all the other cells, and I'm the only available cell in the area, so it will go to me. Another problem here could be that usually the cell with the newest technology is preferred. So LTE, for example, every phone supporting LTE will always connect to an LTE cell if that one is available. If it's not available, it's going to UMTS. If UMTS is not available, it will go to GSM. And again, if I want to force the device to come to my network, I have to do jamming to bring all the Z phones to my network. So if I jam LTE, it will jump to UMTS. If I jam UMTS, it will jump to GSM. And if I'm the only GSM cell available, it will come to me. So again, jamming is the solution here. And there exist also some downgrade attacks where I can just send one packet, for example, and then your phone will fall off its LTE network and connect to UMTS. And there also exist some attacks, again, you can go to GSM. So, how that is looking like? Next demonstration.
So for those who've currently just been trying to find the cell H2HC, as Henrik currently is using an ID of a network that actually exists here, your phones will most probably stick to the actual name of the original network. As such, this short and the long name H2HC will most probably not appear on any of your phones. But yet again, the cell is still there, and you, in theory, could still slide in if it was open.
But that looks interesting. So we just before we started this, the talk, we turned on our cell. Here is that front end for the database, and I see which devices are connected to my cell. But I also see which devices already tried to connect to my cell. So I'm just logging everything. So who tried of you to connect to my cell? And maybe if you take a closer look, you will find your IMSI. So that's your more or less username in your network. So a couple of you, I think the one in the first rows, tried to connect to my cell. A lot of Brazilian SIM cards. So here again, in that username, you find Brazil as country, 72410, I don't know what it is, 03, some providers. But the good one is there exist some web pages to look that up. 10, it's Vivo. So now I can, so even if I'm on a different network, I'm on 01, so it's also Vivo, but a lot of phones are trying to connect to me, just because, again, I'm the loudest cell. And that looks interesting. And that is why it more or less is quite easy to test such devices. Even accidentally, a lot of devices are connected to our network because we are just the one with the best coverage. And we are not using LTE, we are just using a GSM here. So that is how it can work. And now, so again, before everybody is thinking that we are hacking his device, here nobody is authorized, just my 2 test phones. All the other ones are currently not allowed. So they are prohibited to connect to my network, so we are not doing anything with it. But if somebody is connecting with our setup, with this, we can now, everybody can just do normal voice calls, send messages, like in a normal telephone network. So we can act as a kind of stingray or IMSI catcher, even full man in the middle. So we can reroute your traffic through my laptop, manipulate it, and forward it. That is what everything will be possible with that setup. We can even test how the authentication, the encryption is with your phone. Is it supporting that no encryption? Usually it is. So I've seen it just once that an IoT device is prohibiting that, that no encryption is working. Also, I can trigger emergency calls, whatever, so I can fake a lot of stuff. And with the SIP uplink, we don't have it running yet now, so that will not work. We can also route all your calls to the normal telephony network. Then with this setup, we only have GPRS as mobile data, so quite slow. So maybe that could be an indication that your network is not very good, or that you're in such a IMSI catcher scenario, so that you're connected to a Stingray, but we can speed it up. So there are a lot of possibilities, or just use an UMTS base station. But our target now is to bring all that typical pen testing stuff now to an interface, the cellular interface, and find or search for vulnerabilities here. So that is what we now can do. One specialty is the SMS. SMS over GSM has a special modulation. But as I already introduced, there is an interface coming with OpenBSD called SMPP, SMS Peer-to-Peer Protocol. Here, for SMS, there are two variants which are existing, the so-called mobile terminated and mobile originated message. So a message which is coming from the phone is looking different like the one which is going to a phone. For our analysis, we just need the one which is terminated, so we, terminated on the phone, so into the direction of the phone. This is looking like that. So we have a header here on the left, where we can play around with. We can set some bits which more headers are there, and depending on that, we even can push updates. So, for example, the PID here, the PID is defining where the SMS, which is sent to the phone, is routed. There are numbers we can give in. Then your Android kernel is processing the message. Then there are some where your baseband is processing the message. And of course, there are some where the SMS application is processing the message. Or even some more applications can listen on that IDs and process your SMS. So a lot of stuff to do there. We can assess almost every application which is listening on SMS on your phone. And there are more than just the application per default. So the Android kernel is doing that. iOS kernel is doing that, so every kernel will do that, and also the baseband will do that. Because that channel is used to push updates to that part of the, so it's used to push updates to the baseband, for example, to the Android kernel. Or just to change some configuration on your phone. Then we have the in DCS, which is the data coding scheme. There also, again, there are multiple methods to encode your message. We can send pictures, we can just send some raw data, we can send an SMS text message. That is usually what's here. And the UDL, again, are some enhancements like, I want to send you some ring phones, all here. There you can also do some testing on the implementation. How is your phone behaving if you send some arbitrary ring phones which are maybe crashing your device? So there have been a lot of vulnerabilities detected on applications on the phone where exactly that headers have been used for. Because that are not the headers which are normally used just via sending an SMS from person A to person B. So a lot of playground here. That is where we automated it with some scripts to do some implementation fuzzing. That is very important here, and from time to time you really find something which is crashing some applications on your phone, or even more. Here, that is how it's looking like. It's just a short Python script where you can modulate your SMS. There you can just type in every value you want to have. You even can spoof the source address. So there are no checks from which source the SMS coming. Because I'm the provider, I can type in whatever I want. I can type in the source address here, 1001, and all the other fields. So it's quite easy. So I can go through and just send whatever I want. Okay, and Brian will now show a bit out of the practice, out of our work.
So now to the, I'd say, fun part. The story basically begins with we opened the web browser and we started buying stuff on the internet and had a look at it. The first thing that we're going to look at is a very small personal tracker. You can get them on Amazon or from various places that ship stuff from China. It's basically a small, something like 10 to 15 US dollar device. And all that it does is it's got a GPS receiver in it and it's got a SIM card. So the idea is you place it on something or somebody and you want to track it. And so the basic question here, of course, is, how do you control it? How secure is it? The way to control it is very easy. You actually just send a text message with the letters DW in them to the device and it will respond with a text message. Initially, I had actually thought that the device did really use, real GPS, as in satellite-based positioning. It actually turns out, as you can see in the bottom, it actually just sends you the cell ID and the network code. So it basically only tells you where the device is within the network. So it doesn't really do any real GPS the way they're sold, but still they do give you some kind of position. As said, all you need to do is you have to send the letters D and W. Meaning, security of this thing is solely based on the knowledge of the phone number of the SIM card in the device. So if you know the phone number, you can remote control it. Now, the fun thing about these trackers is you can see these little black discs on the side here. They actually have microphones in them. So you send a text message and they will reply with a phone call to your phone, and you can basically tap into the conversations that are on the other side of this tracker. Yet again, only based on the security of the knowledge of the phone number of the device. Now, the fun thing is, let's say we have something like one of those devices in our own cell. The good thing is, we are then the cellular operators. And something that actually a lot of people don't necessarily realize, the SIM card that you have does not contain your phone number. It contains the IMSI, which is a unique identifier for the SIM card. The phone number on the other side is actually just stored in the back end. Meaning that if I have a device in here, so one of your random phones that has tried to connect, and I hit edit and just add a phone number here. Refreshen? Also, warte. Ja. So with this simple step, I've just changed the phone number of a device within our own network. Meaning that if one of your devices comes into the network, although I will not know your phone number, I can assign you a custom phone number of my own, and as such I can reach all devices in my network. Meaning, if you'd have a device like this that is in a critical location, somebody who comes by with a cell can always reach and can control it. As said, there is absolutely no kind of authentication or identification of the text messages that are coming in. So basically, a device like this, it's understanding how it works and you can own it. Of course, security-wise, if you look at it, without this approach of actually using an own base station, if you have a SIM card, nobody will really know the number of this device. So it does make sense that a lot of people actually think that this is a secure approach. You buy a SIM card, you know the number of the device and the operator does and nobody else will. So of course, brute forcing a phone number is highly, complex, and it simply won't work until you find it. But this way, own base station, get the device in, you control it, it's yours. Things like that get a little bit more fun over time. So this is the RTU 5024, which is a GSM gate control device. So the idea is that if you have something like a gate on your yard or if you have a garage, you connect this device to it and you can then basically control the gate via text messages or via a phone call. Yet again, depending on how you configure it, if you take the device out of the box, yet again, everybody can really control it. So that's yet again a question of a few seconds to hijack and attack it. The nice thing here is they actually do have some kind of authentication in there. So when you send a text message, those 4 X's that we have in front of the CC is the command to open the gate, and these 4 X's are basically a 4-digit PIN number. Meaning an attacker will have to know this number before he is able to actually control the gate. Of course, in addition to the phone number of the device. So the big question is, I'm not sure how it is in Brazil, do all of you have something like an SMS flat rate? So you can send as many text messages as you'd like to, meaning if you have to send 10,000 text messages, although your operator will probably notice and might ask you some stupid questions, you can basically still attack the gate on a public network. Of course, if you do an attack like this properly, you don't want to open it. You actually want to own it. So you actually go in and you use a command, you brute force it automatically. And you then go in and you actually just use the command to change the PIN number. So, that's another command. You send the old PIN, you send a new PIN, yet again 2 letters. I think it was CP for PIN change. And you simply iterate all the possible PIN numbers. You send 10,000 text messages. And after a short while, the device will actually send a text message back saying, hey, you've just changed the PIN number. So one of those devices on a gate somewhere that's critical, somebody comes by with a base station, owns it. A work of a few minutes. The next fun things that you can get out there nowadays are home alarm systems. And yet again, here the idea is that if somebody breaks into your house, the alarm system will send you a text message. Meaning, the alarm has been started or somebody has activated or deactivated the alarm. Simply a question of remote monitoring. And here yet again, the approach is they have another new idea. They actually work with the source number of incoming messages. So when I actually unpack it and start it, everybody can yet again control the alarm system, which is a bad state, but you should configure it if you follow the manual. And if you've done that, then your phone number is a secret, which is necessary to control the device. Now, thinking of it, the phone number of the SIM card in the alarm system might be a secret, because you won't pass it on to anybody else. But do you think that your own cellular phone number is a secret? You've got it on your business cards, all of your friends have it, other people that you meet somewhere and that you want to stay in contact with, all of them have a copy of your very own phone number. Meaning if it's your alarm system, I have your phone number, I yet again go into my cell setup, apply your phone number to one of my devices, and I can control this alarm system. Yet again, one of these great things, the alarm system basically relies on the fact that the cellular network is secure. And even though, even the public networks aren't really that secure, as long as somebody is able to spoof a network and to make the device connect to his own network, then there is absolutely no efficient security in place anymore. So the attacker can really do with the device whatever he wants. As said, security is based on the unauthorized phone number, which we can spoof in our system. So yet again, these alarm systems, although the concept behind them makes sense, and although they would be secure in a perfect world, if the device would only really connect to Vivo, to your provider's network, then it wouldn't be a problem, because we wouldn't be able to actually spoof any other devices, and we wouldn't be able to spoof your own phone number. But the device itself is so insecure that we can still attack it. So, loads of fun with that. Then another very fun thing, so this is an actual GPS tracker that does really use GPS. And it's actually made for use in vehicles. So it's got a 12-volt power supply. You basically put it somewhere under the hood of your car. And as such, you always know where the car is. And in this situation, although you can control it via phone calls or via text messages, it uses an IP connection. So as it's a China-made device, it connects to some Chinese web service and regularly uploads its own position. So how does it do it? Plain text, of course. It uses TCP, it's a raw protocol, and if you're just able to see the trace, just from looking at it, you will see the coordinates of the device. So, you know, somebody uses something like that on an insecure network, not even if it's the network of an attacker, if it's just an unencrypted network, which do exist in the world quite a lot. Everybody sniffing the traffic is able to actually see the location of the device. Now, the little issue here is you can do man in the middle, you can attack it, and this very specific system actually has a very sweet vehicle immobilizer feature in it. So the idea actually is the manual literally says go in and cut the wire of your oil pump. I still hope that they actually mean the fuel pump and that they've, you know, had a small mistranslation. Just a thought, if the fuel pump in your car dies, then the car will run out of fuel and the vehicle will stop. If your oil pump will stop working, your car will still work until it basically overheats and is kind of rather destroyed than stopped. That's a very efficient way of immobilizing a vehicle, but not necessarily the smartest if it's your vehicle. And here yet again, the issue is, as all the communication that we have is in plain text, an attacker with a base station like this can drive past your car that has one of these immobilizers in it, can hijack the connection and can basically send a signal to your car to stop the car. And that's an attack, if you've had a look at it, it takes about 5 minutes to set up. Now yet again, the question is, how do I get a car to actually connect to my cell? As Hendrik said, there are basic cell connection mechanisms that you can use and that we can misuse. But you know, if you actually want to cause damage, you do it in a tunnel where your cell is the only cell that you have available. So basically the vehicle has no choice but to, well, it would have a choice to not connect to any network, but it always wants to be online. So do it in a tunnel, the vehicle will connect to that, will connect to your cell, and you basically have full control over the immobilizer. So this immobilizer is one random one that I bought from the internet. There are many, many, many more like that out there. So if you should decide to use something like that, just leave them. They really aren't necessarily a very, very good idea to use. Here yet again we have the point of what Henrik had already said, these fun custom APNs. So quite a few embedded devices nowadays, especially the ones in automotive, they use a special access point name that is only used by the specific vehicles of a certain brand. Meaning that only the vehicles in that brand can actually connect into that network, and there usually even is some kind of authentication in place. Now the fun thing is, it's only the car authenticating towards the network. It's not the network authenticating towards the car. Meaning yet again that even if something like a custom APN is in place and is used, it basically offers absolutely no extra security. And we've also already done it in a few proof of concepts. You know, if you do really want to intercept the valid communication of a vehicle like that, it might cost you a little bit money, but you just have to buy your own telematics unit. And then you use the SIM card that's in that telematics unit and put it into your own LTE stick. Meaning that LTE stick with that SIM card is able to connect to the vendor's network. And as soon as a vehicle is in our network, we can use that uplink to basically intercept all traffic that is there. So all these mechanisms that many vendors out there rely on, they are a great idea in a perfect world where you don't have any custom base stations and custom cells. But this stuff, as said, is out there, so it's always very easy, great, and fun to break it. Yeah, you can copy the whole stuff and get into there. Sorry for skipping there. So what we've seen now is stuff like device control via text message. One important thing, you know, if you've done some research and if you talk about the stuff, is always to give some kind of recommendation to vendors and people who actually work with the stuff. And sadly, really, device control by text message is this one mechanism where you just can't give any hints in how to do it in a secure way, because there simply isn't a solution, especially if you keep something like usability in mind. So if you have something like a home alarm system, the idea and the concept always is that the person who's using it is able to write a text message with his fingers into the phone. Something like what we've seen, a command that is just DW. It's 2 characters, it's easy, it's quick. The moment where you actually start to add some proper encryption or authentication, that is something that you won't be able to actually learn by heart anymore. And even if we'd have something that's a proper password and not just a 4-digit PIN, that's then a 2-stage attack. So I wait for you to go home to try to open your gate. I force your phone into my cell, I intercept one of your text messages, and I've got your static password. And afterwards, I'm able to, yet again, create an own text message and control the device that you're working with. Meaning all this stuff via text message, as long as it's actually usable by a normal person, is highly insecure, and there sadly isn't a way to do it in any better way. So if you have something that is controlled via text message, think about it twice if you really want to use it, and if you want to use it in, well, let's say a critical situation, somewhere where it's really important, because an attacker will always be able to get in. Device control via phone call yet again. The basic idea here is a text message might cost you money. A phone call yet again, if the call isn't established, you just let it ring once or twice, is free. So many devices simply do something like that. You ring in, it rings once, and yet again something like the gate opener will just work and the gate will open. Valid approach yet again. Also here, if you use an own base station and attacker has equipment like that at hand, there is no way to use it in a secure manner. So an attacker will always be able to actually attack the device. And especially if you think about it, attacking a moving object like a car via RF is always complicated because you've got to be in a certain vicinity. But if you're talking about something that's a gate control or a door control, that thing will always be in the same place. And even if it doesn't work the first time round, you just come back 2 nights later. It's still there, it will still work, and you can still try to attack it. So with all this stuff, attackers have an enormous amount of time to actually perform their attacks and to perform their preparations. So it's simply yet again a mechanism that you shouldn't use and that you sadly can't rely on in any way. Now the fun and sad thing is device control via IP. So if you think about it in the normal network world, I guess everybody here knows what SSL is, and that's something like SSL or simple transport layer security or encryption is one of the most important and critical things that we have out there, because communication has to be secured in some way. Now the sad thing here is, if you look at it, in devices that have been developed by professional IT guys, there are loads of bugs and loads of vulnerabilities in there. And now on the market, we have, for example, companies who've been creating coffee machines for 30 years or even longer. And those technicians are really great in making coffee machines. And now they're sitting there and it's their turn to implement a network stack or remote control. They will do exactly the same mistakes yet again as the IT guys have done many, many years ago. They're a separate group. They don't necessarily look into what's out there. They will just do exactly the same mistakes. And that's something that really, especially in the cellular world, we see quite a lot. There yet again, there is a second aspect. So if you look at some operators' publications, every operator will tell you that their network is secure and that you can rely on it. And that's what many manufacturers do. They go in and say, hey, the device will run on a public network. Public networks are secure, so we don't need to apply any kind of protection on transport layer or on application layer. Yet again, as you've seen with the stuff that we've got here, the attacks are possible, they're feasible. meaning here to protect IP communication over cellular devices. It's the same rule and it's exactly the same approaches that we have in every other network field, but it also has to be applied. And sadly, that's something that's not really happening today. Meaning that the more of these devices get out there and the more people actually are able to attack the stuff, the more stuff will go wrong. So the other question is, if you have something like a device control via a custom app that you have installed on your phone. Some of these devices use text messages, and the home alarm system that I've shown is one of them. But instead of actually using some kind of proper signatures or whatever for the text messages, these apps very often use exactly the same interfaces or APIs as the user can use by hand. So meaning just because you've got an app that looks fancy or has security written on it in big letters, doesn't necessarily mean that it helps. It's the same approaches, and as long as the device can be controlled insecurely via text message, and you can control it via app, the text messages will always be the weak point. So the stuff simply stays insecure and attackable. So, as a small summary, IoT testing is fun, it's great, especially due to the fact that there's so much stuff out there that is completely broken. So I actually thought about starting a talk like this and basically just calling it manually owning a device. Manually as in reading the manual and actually picking the vulnerabilities just from the usage instructions. And that's really something that in this field you can do very, very often. You open the manual and you see, hey, that's the way how to control the device. And you will never find something like PIN or authentication or password. You just see send to control. And that's the way the stuff out there really is. So it's really that easy to have a look at the stuff and to break it. Most of the stuff that we've done, we do fully automatically. So the interfaces and the configuration that Henrik has shown you, either by using something like the SMPP protocol or in OpenBSC using a command line telnet interface. You go in and you use a command, send text message to device. You script that in a Python script or something else, and you can do fully automated testing. And if you do something like that, currently you will find stacks of vulnerabilities and issues. Then, of course, you can go even lower. Sorry. So most of the stuff that we've been talking about today is basically on application layer. But you can also go down and do proper SMS fuzzing, as Henrik had described. Meaning not changing the content of the text message, but really changing the format of the text message itself. And yet again, that's a part of research. There are people out there that are doing it, but there simply aren't a lot doing that work nowadays. So lots of the stuff out there will be vulnerable to very fun and very simple attacks. So, summary. Well, attacking cellular devices is easy. Was a very long week. The equipment that we've used here, so the software is all open source. The base station that we have here, you can buy on eBay for between $100 and $200 US. So, that's something for a small budget. If you want to get professional equipment, you will have to pay something like $2,000. Which yet again for a motivated attacker is an investment that people will actually do and go for. So with the stuff that we've got out there, the tools are on the market, there are enough motivated attackers out there, so loads of IoT devices that use cellular uplinks are insecure and they will break in the short future. And yeah, we'd be happy to get you into breaking that kind of stuff and seeing what others can do. And I can just recommend, if you've got the time and a little bit of money on hand, give it a try, break some stuff. It's really fun. It might cause a certain amount of nightmares, but that's certainly worth it. And with that, thanks a lot. If there are any questions, feel free.